Hi guys, welcome to another tutorial video from Knowledge is Fun. Today we are going to look at the binary number system. The easiest method for converting binary numbers to its decimal equivalent is what we are going to learn today. Continue to watch this video because it's going to be very interesting. Okay, the binary number system. Now, what do we understand by the binary number system? The binary number system is a system of mathematical expression which uses only two symbols, typically known as zeros and one. It is a system expressed in base 2. Okay, so base 2 is the same thing as when we say binary numbers. Okay, all right, so binary numbering scale. Now, if you look at the screen, you will see that the base 2 numbers are in 0, 0, 0, 0, 0, 1, and like, and then its equivalent in base 10 is 0, 0 means 0, 0, 0, 1 means 1, 0, 1, 0 means 2, like that, okay, down to 7, okay, and then 2 raised to power 0 is 1. That's the position value. Now, in mathematics, any number raised to the power of 0 is 1. For example, if you have 1 million raised to the power of 0, it would give you what? 1. Okay, so now 2 raised to power 3 means 2 into 3 places. 2 multiplied in 3 places. That's 2 times 2 times 2 gives you what? 8. Okay, so that is what this means. Alright, so now hexadecimal number system. Now, what do we mean by hexadecimal number system? This is the name of the numbering system that is base 16. This system therefore has numerals from 0 to 15. Okay, do not forget, base 2 are numbers 0 and 1. Base 3 are 0, 1, and 2. Base 4 are 0, 1, 2, and 3. Then base 5 are 0, 1, up to what? 4. Don't forget. So base 15 is called hexadecimal, which are numerals between 0 and 15. Okay, now that's 2-digit decimal numbers. Okay, you have numbers like the 2-digit decimal numbers here: 10, 11, 12, 13, 14, 15 are represented by what? Letters. Yes, in hexadecimal system, 10 is represented with the letter A, 11 is represented with the letter B, 12 is represented with the letter C, 13 is represented with the letter D. This is an hexadecimal number system. Now, don't forget that the binary number system is important because of its relationship to computer circuits. Binary numbers only have 2 digits, as we mentioned, zeros and what? 1. Likewise, a computer circuit can only be in 2 states, either a off or on. Now, when you are talking about off, it means it is what? 0, and when it is 1, it means it is what? On. Okay, all right, let's continue. Boom. Now, just like I said, the easiest method for converting the binary number system to base 10 is the use of multiplication algorithm, and then we're also going to learn here. I'm going to show you how to multiply the binary digits by increasing powers of 2, starting from the right, and then we're going to find decimal numbers equivalent, sum of those products together. Okay, just watch along. All right, now this is base 10 to binary. Okay, now when you're converting from base 10 to binary numbers, we're going to be dividing by 2. How are we going to do that? I'm going to show you now. So we're going to take an example now to buttress our point. Okay, all right. So now the work example here says convert 105 base 10 to binary numbers. So how are we going to do it? Boom. We're going to keep dividing it by 2, and then this is how we're going to do it. Now you're going to convert 105 base 10 to binary numbers by dividing it by what? 2. Now why are we dividing it by 2? We're dividing by 2 because we're converting to binary numbers. So anytime you're converting a number into binary numbers, you must make sure that you're dividing that number by what? 2, especially if the number is in base 10. Okay, so we divide 105 by 2, and then we have 52 plus 1, which means remainder 1. Okay, so when you, because if you multiply 52 by 2, you're going to get 104. So when you subtract 105 from 104, you're going to have what? 1. So the plus sign here can also be written as remainder 1. In some books, you see it as R1, that is 52 R1, or REM, which means REM1 or remainder 1, whichever way it is. And then you have it this way: 2 in 52 gives you 26, remainder 0. Okay, 2 in 26 gives 13, remainder 0. 2 in 13 gives 6, remainder 1. 2 in 6 gives 3, remainder 0. Now 2 in 3 is 1, remainder what? 1. Now 2 in 1 is impossible. That's why we're writing 0, and then we're writing remainder of digits there. Okay, now it's very compulsory. When you have a number at this point, when you have a number at below this point here, now if this number, if it's smaller than 2 or smaller than whatever number you're dividing with, now when you divide that number by the divisor, if the number is smaller than the divisor, of course the answer or the operation becomes, or the answer, sorry, becomes 0, while the remainder becomes that number, because it is impossible. Okay, so it is accepted in binary number system. Okay, so now we have our remainders populated here. Now what do? We are going to write our remainders in an upside down position. So it means that we're going to write it from down up. Okay, so you can see the answer. It says here 105 base 10 equals to 1101001. So you can see we wrote the numbers from beneath to the top. Okay, all right, so let's move on. We're also going to take another example to explain well. Okay, now we're going to convert 10010 base 2 to base 10 number and base 8 numbers. Okay, so we're going to learn how to convert base 2 to base 10 and from base 2 to other numbers. Okay, so now what do? Boom. So when we have it like this, remember we made mention here in the first slide that we're going to use multiplication algorithm. Okay, so this is an example of multiplication algorithm. Now whereby we multiply each value of the base 2 by 2. Now don't forget we're converting to base 10, so we're going to multiply 1000110 by 2, placing pairs. So we're going to place these numbers, the subscript numbers up here are called pairs. So you have 1 times 2 plus 0 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2 plus 0 times 2, and then we're going to place power from 0 to the last digit. So 0, 1, 2, 3, 4, 5. Okay, now what are we going to have? Okay, boom. So we're going to have it here. Now it says here, do not forget, I said any number raised to the power of 0 gives you what? 1. So 1 times 0 gives us 0. 1 2 raised to the power 1 is 2. Okay, times 1 gives 2. 2 raised to the power 2 equals to 4 times 1, 4. 2 raised to the power 3 is 8 times 0. You see, it gives us what? 0. 2 raised to the power 4 is 16 times 0 gives what? 0. All right, do not forget. When you have zero and zero in between numbers, for example, the product is just going to be zero. You understand? Because no matter how you square it and then you multiply by zero, it's still going to have zero. So 2 over 5 is 32 times 1 is 32. So my final answer is what? 38%. So we've been able to convert 10011 base 2 to base 10 using the multiplication algorithm. Alright, so now we want to learn how to convert the same number to base 8. Now don't forget, before you convert a number, before you convert a base 2 to another base, you first have to convert to base 10. You just have to convert to base 10 before you do it. Now, this method is very simple. Okay, now what are we going to do? Now, see, I'm splitting this base 10 into 2, whereby you have 32 plus 6 is what? 38. Don't forget, this is 38. It's a decimal number. So I'm just expanding it this way. Boom. Now, what do I have here? Now, 4 times 8 raised to power 1 gives me what? 32. Okay? Because 8 raised to power 1 is 8 times 4, and that's 32. And I have 8 raised to power 0 is what? 1 times 6 is what? 6. Now, you may be wondering, why do we have the value 8 here? Now, the value 8 here, do not forget, is what we're converting to base 8. Okay? We're converting to what? Base 8. The very first thing we did was we expanded 38 to base 10. We expanded base 38 to base 10. It's still in base 10. And then we multiplied by 8. Okay? Bam! So our answer becomes 46. Okay? Do not forget. Our answer will give you what? 46. Now, in this B, what we did was, what we did in the B is, it shows that when converting between bases, it is usually easiest to find the equivalent generate, that is base 10 or base 10 numbers, as an intermediate step. So that was what we did. You see, we split 38 into 32 plus 6. Do you understand? Okay, believe you understand. Alright, so therefore, that is the bottom of 6 base 8. Okay, so let's look at another example. Yeah, it says we should use repeated multiplication to convert 11001 base 2 into base 10 numbers. Okay, so we're going to do that. And are you seeing it now? Look at it carefully. In this example, we are going to use what they call repeated multiplication to convert base 2 to base 10. Now, 11001 is written this way, and then you're going to multiply by 2. 1 times 2 gives us 2 plus 1. So we're bringing out this 1 down, and then you have 2 plus 1 gives you 3. So 3 times 2 gives you 6, and then we're going to bring down this 0 down, and we have 6 plus 0 gives 6 again, and you keep multiplying by 2, and then you add to the next digit, and then you multiply by 2, and then add to the next digit until the last number. Then the answer is what? 25. You might want to test it by using multiplication algorithm. You're still going to get the answer. It's very simple. Alright, now converting base 2 to base 10. How do you do that? Very simple. Do not forget that bases are binary numbers are important because of its relationship to computer circuit. Okay, now so I may mention about the on and the what off, so the exponent and then the calculation. So these are methods in which you can use to solve this too. You can understand it as a computer circuit. Okay, so now converting base 2 to base 10. 10011. Now how do we know if it is on, off, it is on or off? I mentioned that the off is denoted as 10, while the on is denoted as 1. Okay, do not forget. So that's how this is being achieved here. Alright, so the exponent means that exponent same thing as what power. Do not forget, when you multiply 1 times 2, 0 times 2, 0 times 2, 1 times 2, 1 times 2, and then you sum it up. Don't forget to add the powers, which are here. You have 0, you have 1, you have 2, you have 3, and then you have 4. Now 2 raised power 0 gives 1, 2 raised power 1 gives 2, 2 raised power 2 times 0 gives 0, 2 raised power 3, 8 times 0 gives 0, and 2 raised power 4, which is 16 times 1 gives us 16. And then 16 plus 2 is 18 plus 1 what? 19. Very simple. I believe you enjoyed this tutorial video where we are able to explain extensively about the number or the binary number system and methods of calculating binary number system. Now, if you find this video very interesting, please hit the like button so that YouTube can show it viewers. Do not forget, you can also click on the share button so you can help share to your friends and families or colleagues. Do not forget to subscribe to this channel. I'll see you in the next video. Bye bye. Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Knowledge is Fun by Oladiji Aka, so I can always keep making videos, and also feel free to email me at oladijidws@gmail.com. Thank you. Bye bye.